Okay, this of course was dealing with inverse trig, and you have found in the past the inverse of an algebraic function. The basic steps are very, very similar, and anytime you find the inverse of a function. Step 1, write the original function. Step 2, replace the f of x with y. Step 3, switch the x and y or interchange them. Step 4, solve for y. And step 5, replace that y with f inverse of x. So this is an actual trig function as opposed to an algebraic. And you're given the function as being f of x is equal to 2 sine x plus 3. This is the domain of this function. So this will end up being the range of the inverse. Okay, that's your function. First, f of x becomes y. Interchange the x and the y. Now your objective is to solve it for y. So I'm going to move this 3. It goes to the left side and becomes negative. I don't want this 2 right here, so I divide both sides by 2. So now I have sine y by itself. But in order to get rid of sine, I have to take the inverse sine of both sides. And then these two cancel. We're left with just y. So inverse sine is equal to x minus 3 over 2. Okay, is that everything? No, your last step should be to replace the y with the f inverse function. So it's the change of notation. This part is still the same, but instead of y, we have f inverse. The domain of the original function was negative pi over 2 is less than equal to x, which is less than equal to 2. The range of that function. Think about how you would graph that original function. You'd have a center line at 3, and you move 2 units down to get 1 and 2 units up to get 5. So the sine graph would have actually been between 1 and 5. So that would be your range. Then what happens? The range of the original function becomes the domain of the inverse. And the domain of the original function becomes the range of the inverse. They just flip-flop completely. So be sure you realize this is the actual inverse function, the domain and range of the original, domain and range of the inverse.